So, here we are. It's time to learn how to set up a lab submission to be turned into Chris Lorelli's Digital Fundamentals, CETT 1325 at Central Texas College. First thing I've got open here is our announcements page, and you'll see on the announcements page there is a assignment submission tutorial, and we are currently working on the video to go along with that. However, there is a document, Lab Submissions. So if we click on that document, download it, and open it up once it's downloaded, you'll find four things. There's actually five, and we're going to add that fifth one right now. And that is the specification. The specification is what are you assigned to do with this lab procedure that you're doing. It doesn't have to be a big, drawn-out, complex explanation. If the lab says build a 3-input NAND gate, then that's what your specification is. You just have to inform me what your intent was on this lab. Second thing you're going to need is a schematic for that lab. Then you're going to need a layout diagram to go with the actual build. And maybe I should move these around a little bit. So there we go. So you need a properly labeled, clear image of your neatly assembled circuit. What that means is the image itself has to have a proper label on it. I do not know what your camera or your telephone's file number means when you send me an image. But if that image says Lab 3.4 Procedure 1, I know what that is supposed to be accomplishing. And why don't I spell labeled right while we're at it? There we go. And of course, your build, the actual hardware build, has got to be done neatly. Okay, then we need a layout of the build. So where did you put your parts? And then any other documentation required by the exercise. So sometimes there's going to be a truth table. Sometimes there is going to be a what happens when you did this. So you have to explain your results, or you have to show your results in a table. So that is the other documentation. Now the document goes on to explain some things, and it shows a build that I did for another project. We're not going to do this one today. We're going to do something a little bit simpler. So now we can close out that document. Do I want to save changes? Yes, I do, because I want to put those into the school. All right, so let's start out with the specification. So our Lesson 3 labs, there's my title. My specification, Lab 3.4 Procedure 1, is to build a 2-input NAND gate. So there's my specification. Now I need a schematic. Well, I can hand draw a schematic. I could take a picture of the schematic in the book and make sure I've labeled all the pieces in the book. Or I can generate a new schematic. Now, sometimes the book doesn't give you much of a schematic. It tells you to build this one picture, but you have to do it with a bunch of different parts. So you can't always use the book's drawings. And in those cases, well, that's where Logism comes in very handy. Okay? Because this is a CAD program for logic. Now in this case, I just want to get a 2-input NAND gate using an actual 2-input NAND gate. Now with Logism, I could build this out of other primitives. These guys, these three up here, you can build any gate combination using just these three parts and a combination of those parts. But in this case, we're actually going to use the part designed for it. All right, so I put down a NAND gate. Now I've got the properties for that NAND gate. Number of inputs. I only want a 2-input NAND gate, so let's go up and select a 2. We're going to label that NAND gate. U1, and since the package has got multiple gates in it, we're going to call that U1A. So we know that's the first one in the package. And we can then give it some inputs. Give an output. Now, according to the book, the output of this is going into a LED. So let's grab an LED. I realize this is not the proper schematic representation of an LED. However, since this is a simulator program, it puts in an LED that will light up and turn off. So I'll accept, in logism, this symbol of an LED. All right, that LED is tied to ground through a resistor, and that resistor is a current limiting resistor. It keeps you from putting too much current through the LED and burning it up or burning out the output of your IC. Those of you that haven't taken DC circuits yet, or don't plan on taking DC circuits, that is part of Ohm's law. You put a resistor in to limit the current. The more resistance, the less current. Okay, now let's get some two inputs here. And the first input we're going to label as A. And we're going to make sure that label is to the north. And now we need to label the other input, and we're going to label it as B, and we're going to label it to the south side. Now we have to label the actual pins on the IC itself, because if I can't rebuild what you've built, then it's not a complete project. So you have to tell me what pins you used on U1A. So that would be pin 1, pin 2, pin 3, and what kind of component is U1? Well, let's get the labeler out again. And 74LS00. Okay, now I have to label my output LED. So I'll select that LED and give him the label of DS2. And we're going to label him to the north. There we go. And then the pull resistor, we're going to give a label of R2. And the reason why I'm giving this DS2 and R2 is because our voltage regulator circuit uses DS1 and R1. And you're always going to have that circuit on your board. So you have to leave those in place. And the value of R2, let's move R2 over a little bit. This is not a Star Wars reference. $470 ohm. I always do that when I'm labeling. I forget that this does all caps. And once again, we'll move that label over so we can read it. And now we'll double check. Our inputs are inputs A and B on pins 1 and 2, output on pin 3, U1A, 74LS00, going into a component DS2, which also has a component R2 at 470 ohms. All right, from this schematic, I can build this circuit, no problem. We'll go File, Export Image. I'm going to send it out as a JPEG. I've got a demo project file here. Okay, I've got a demo project file sitting on my desktop. I had to answer the telephone. And in that project file, I'm going to want to put a label of Lab 3.4 Procedure 1 schematic JPEG, and I'm going to export that, and it's going to replace that because I already did this once. Okay, so I've replaced that, if I wanted to check the simulation, make sure that of what the pattern should turn out when I actually do it via hardware, I'm going to hit my finger tool and change the values at the input. Anytime I get a 0, it should light up. 2 1s should turn it off. There we go. So I know my schematic is right for the components that are involved here. I've already got an image of it, so I can now get rid of that. Discard it. Now I'll open my demo project folder and my Word document one more time. So I've got my input, or my specification, procedure 1, input. Let's get my schematic in there. So here's my schematic, which I will place right there. Schematic's ready to go. At this point, I can build the circuit. So I would go ahead and build the circuit, and if I open up my camera, what you will find is my circuit completely built with the sun shining on it all of a sudden. It's been cloudy all day long, and just when I want to show the video, the sun comes out. Okay, there's my circuit, including my battery. You see there's no extraneous wires going to and fro or anything like that. It's because I only want to see what's there. I have had students in the past try to pull one over. They couldn't get the circuit to work, so they wired the LED to a battery off camera, and they were turning it on and off via the off-camera stuff. Don't want to see that. I'm not saying anyone else would do it. Those were a couple of sneaky guys trying to work together, as a matter of fact. They didn't last. Okay, so I'm going to apply power here, and you can see with a 0 going in, and that will be, oops, this wire right here is going to pin 1. It's tied to ground. With the ground, I'm getting a LED lit up there. If I take that wire off of ground, put it back to a +5 source, giving it an effective logic 1, you see that the LED went out. When you are doing your projects, you're going to be filling in a truth table, so you're going to go through all the combinations of the inputs. The only thing I actually want to see a photograph of is the initial state with nothing on, and then a state where something should be turned on. So 2 state photos, that's all you got to show me. Now those photographs have got to be clear, and I'll give you a demonstration. Now, I've got this built. I take a picture of it. I take a couple pictures of it. I take at least 3 pictures of it, as a matter of fact. Because the first picture is going to show me the general build. Okay, and this is the exact circuit you just saw. It's going to show me the general build of the circuit. And here you can see all the wires, nothing extraneous hanging off the board. My power LED is on, so I know it's ready to go. The resolution on this picture is 150 pics per inch, and it's basically a 3x5 or a 5x3, as the case may be. The reason why I suggest you go with this kind of size is because you're going to be uploading the document with several pictures in it up onto the server at the school, and that's how I'm going to get it from you. If you make the pictures too high a resolution and you end up with a 10 megabyte picture, it's going to take forever for you to get it loaded up, because the server is very slow when you're uploading to the school. But if you make it just a small size like this, number 1, it's going to give you a fast upload. Number 2, it still gives me enough resolution where I can pull it out of your document and focus in on it and still see the marking on the chip, the markings on the board, the pins. I can see where the pins are. I can see where the wire routing is. I can see the color codes on the resistors, which tells me you're using the right value resistor. I can do all that kind of stuff if you just make the resolution 150 pixels per inch and then the picture's at 3 by 5. So that's the first picture you're going to give me. And we're going to label this assembly. And just drag it and drop it. Now the resolution is going to remain even though you can resize it in the document. Okay, second picture you're going to give me is a more of a close-up picture of the build that gives me a clear view of everything. Okay, now that you've shown me that the only connection is the battery, you can get a little even closer. And once again, I'm able to get close. I'm able to move things around where I can see exactly what you've built here. Okay, and this is the first picture with an off state. All right, I've got both inputs tied high, which in this case, this LED should not be on. Then you're going to give me a picture of an on state where one of these guys is moved to low and this guy's turned on, and that's what we expect, and it matches your truth table. So you don't have to give me 6 pictures for all the states of the image or of the circuit. Okay, so this guy, same thing. We're going to just pull him down and drag and drop him. I say again, we're going to drag and drop him. And then resize so he doesn't eat up all the space in your document. Okay, there's the two of the assembly drawings. Let's grab the third here. I'm pretty sure this one's an on state. Nope, that was the layout. So hang on, we're going to take that back out again. All right, so assembly drawings. Assembly drawings are done. Now let's add in the layout. It's very possible we're going to need the second page, so we'll grab the layout picture and drop it right on in. Now, the layout photograph, I used my image editor, just took the same picture that I used for the assembly, but I dropped labels on the things. So as I said when we did the schematic, our voltage regulator circuit, which is going to be the very first project you do, always remains on the board. So that's that section there. That will always remain on the board. So it should always have these designations: voltage regulator 1, VR1, R1, and DS1. And then as you put other components on the board, you label accordingly. So the schematic we just drew is actually for those components there. U1 being my IC, DS2 is my LED, R2 is my resistor. Once again, they're clearly marked now, and I can read the values. All right, so now I've dragged that into my document. I may as well move my layout tag downward so it goes with the image. There we go. So, specification, schematic, the neatly labeled image of the build, and I should label each one of these. If I was to do a second build in the same lab, so a second procedure, then I would come down here and give that procedure its own name. But there's still some documentation needed, so we need to put in a table, because with a single IC, they're going to ask for a truth table every time. So I'm going to insert a table, and it's going to be 4 rows, 3 columns. And I can take those columns and I can shrink them up because they don't really take a lot. First row in that column is my labels. Okay, and let's see here. We're going to want to center the text. So this is input A, input B, and the output. And let's go ahead and center all this up so it's nice and neat for us. So first state is all zeros. All zeros, I should have a 1 out. And if we were to go through, oops, I need 1 more row. There we go. And oops, 0 tab, 1 tab, 1. There we go. As we go through the inputs, you'll find that that is the output pattern that you end up with for those given inputs. And we definitely have to label this as the truth table. There. This lab is now ready to be submitted. So I can save it. So it's saved as Lesson 3 Lab. Now to submit it. To submit it, we're going to go to Lessons, go to Lesson 3, click on the Lesson 3 Lab Assignment header, and it's going to come up with a thing for you to submit through. So you can attach the file, browse my computer. In this case, we're going to the desktop. We're going to the demo project file. The Lesson 3 document is now ready to go. You can write your comments, questions, anything you need to say with it. And then you can submit it. Okay, now for me, it's not going to go through the submission because I'm not in the class. I'm running the class. However, it will come back and give you a green bar if it's successful, and it may take a while depending on the size of your images. If you make the images as I suggested, you should have no problem. It should go fairly quickly. But if you just take a picture with your camera and try to shove it up there, it's not going to go so well. But there is the format for submitting your assignments into me. If you have any questions, don't be afraid to get hold of me. I'm always happy to answer questions and provide you with any feedback that you need, any help that you need. So that's about it. We now have the Logism. You know how to use Logism because you did that tutorial, and now you know how to submit assignments to me. So let's see if we have a good year. See you in class. Bye.